Alrighty, good morning everyone, and welcome to another one of our winter webinars. Today's topic is Crush 'em, Pound 'em, Grind 'em, Our Impact Mills with Smashing Success in Canada. My name is Riley Root, and I'm a Crop Extension Specialist with the Saskatchewan Ministry of Agriculture in the Prince Albert Regional Office, and I will be chairing today. CEUs will be offered for CCAs on this webinar. In order to get credit, you must attend the entire live event. We will have a QR code at the end of the presentation to collect your credit. If you missed the code, please email us afterwards and we can work with you to get it. Before we start, I have a short presentation here. I'll try to get through it pretty quickly, but you can also find it in the upper right hand side of your screen there in the resources. So our crop extension specialists, we put this on each year. We work out of 10 different regional offices across the province. We have a wide variety of specialists that can help you with any agriculture-based questions. To connect with our specialists, please call your local regional office or the Ag Knowledge Center at the number provided. There are 8 AgriArm sites located across the province that are dedicated to bringing the industry Saskatchewan-specific information and demonstrations on the new and existing agricultural practices. To learn more, please scan the QR code here. And they also have some field days this summer, so please check this out if they're near your area there. If you ever heard the words on the radio, Saskatchewan is 98% completed harvest this week, then you've likely heard of the crop report. This is written by crop extension specialists each week, and it's just kicking off now. So I'd like to thank all the current reporters and ask you guys to sign up if you're not one, so you could scan this QR code here. I also want to mention that the Crop Diagnostics School is going on again at Scott Research Station on the 23rd and 24th of July. More details will be coming on this, but save the date. Lastly, I just want to make sure everyone is aware of some funding available. You can reach out to your local ag program specialist to find out some funding that you may qualify for. Along with this information, we have additional resources for everybody under the handout section in the chat box area of the toolbar on the top right of your screen there. These will be shared along with the recording after the webinar is complete. Today's presentation will be followed by a live Q&A with Breanne Tidemann. The main hub for today is your webinar screen, and as mentioned, we will share relevant downloadable handouts with you in the chat box area. The entire session will be recorded, so if you miss anything or wish to revisit the presentations, you will be able to. Recording links will be sent out later this week in a follow-up email, and an evaluation will pop up at the end of the webinar this morning. Please ensure that you fill that out. It'll help us determine what you guys want to hear in future events. So before we get started, just a few more housekeeping notes. If anybody has any questions during the presentation, you could type them into the question box in the right-hand side of the control panel there, next to the resource button. We will try to get to as many questions as possible. Your questions will remain anonymous and only be sent to me. During the presentation, you will be muted so that we can ensure there's no feedback. Alrighty, so that's it. Now let's get started. Dr. Breanne Tidemann is a research scientist with Agriculture and Agri-Food Canada in Lacombe, Alberta. She grew up on a farm in west central Saskatchewan, but completed all of her degrees at the University of Alberta. She holds a Bachelor in Science, Biological Sciences, and a Master's and PhD in Plant Sciences, with projects focused in weed science. Breanne started with Agriculture and Agri-Food Canada in 2016 as a weed scientist. Her research program in Lacombe focuses on integrated weed management strategies and novel weed management practices, as well as weed biology and ecology. So welcome, and please start whenever you're ready.
Perfect. Thank you so much, Riley. Good morning, everybody, and thank you for tuning in. We get to talk about impact mills today and whether or not they are a smashing success, and the pun there is fully intended. Before we get into it, I just need to take a moment to thank my technical staff and the students that I work with. They are the ones that are out getting covered in dust on hands and knees, trying to find individual weeds that are popping out of the ground and all of the not necessarily so fun stuff. So a very big thank you to them for all of the work that they do on behalf of our research program, as well as a thank you to all of the research funders of my research program. So all of the crop commissions and different groups that you see here are funders of my research program, and we are incredibly grateful for their support on conducting research on weeds. So why are we even talking about impact mills? Well, there's a number of reasons. Herbicide resistance comes to mind in terms of trying to look at alternatives to manage herbicide resistant weeds. Folks that are in organic production are looking for alternative weed management strategies, potentially to tillage. Okay, we're looking at long-term sustainability, not only of our agricultural system, but also of being able to utilize herbicides. We're trying to extend their usable lifetime by introducing alternative tactics. As well as there's a lot of interest recently in managing volunteers, particularly for seed growers would like options for managing volunteers from their crops. And so there's sort of interest in all of these different areas or different perspectives for why people might be interested in impact mills or in the bigger picture. So we're going to start by just talking very briefly about resistant weeds. We see about 2 new herbicide resistant weed biotypes every year. We're sitting at about 86 or so in Canada. Those are the ones that we've found. So more than likely there are more that we haven't found, because it seems like the more we look, the more we find. So if we continue to look, we will likely find more. So we're sitting around 86, and what you can see is we are just continuing to increase. Okay, it's not surprising. We're still applying herbicides. We're still applying a selection pressure. So we're seeing the evolution over time. So harvest weed seed control is sort of the bigger picture that impact mills fit into. So we're going to talk a little bit about this entire sort of group of control tactics quickly first. What is harvest weed seed control? It is a paradigm of weed control that's really been developed and refined in Australia. And the goal here is to manage weed seeds that are still in the field at harvest and prevent their dispersal. So what typically happens is when we go into the field at harvest, any weeds that are still left in the field will go into the combine at the same time as we are harvesting our grain. Now, a lot of those get sorted out from the grain. Some will go into the grain tank, but a lot of them are coming out the back of the combine in the chaff and the straw spreaders. And the majority of them are coming out, we believe, in the chaff from the work that's been done. And all we're doing by using the chaff and straw spreaders is spreading them evenly across the surface to be next year's problem. Okay, we are essentially putting them back into our seed bank. And the goal with harvest weed seed control is to stop doing that. Let's stop building our seed bank. Let's stop broadcast seeding these weeds to be next year's problem. Now, there's a couple things that we have to keep in mind. For harvest weed seed control to be effective, those weed seeds must still be on the weed plants at the time of crop harvest. Because if those weed seeds are already dropped to the ground, we don't have vacuum systems on combines that are sucking those weeds off the ground. They're already gone. So those weed seeds still got to be on the weed plants. They need to be produced at a height where they'll be collected by the combine. So for something like, say, kochia, we'll get a lot of those seeds. But that little bottom part will have seeds that we're also not collecting. So we're missing a proportion or a percentage of them, okay? The third one is you need to be able to collect the weed with the combine. Now that sounds really silly, but it's something that I saw when I actually had an opportunity to go to Australia. We were working with these big mustard type plants, and they were really big and bushy to the point that they would roll up onto the combine header and off the side without actually feeding into the combine itself. Okay, so at that point when I was standing in the field watching them roll off the header of the combine, I went, huh, so the seeds are retained and they're nice and high in the canopy, but we can't get the combine to actually take the things in. Noted, we've got a third point that we have to add here. Now, there's a lot of methods of harvest weed seed control. So I'm going to go through these quickly with a little bit of sort of a pro-con mention of them. Sorry, I thought I had that all closed out. Chaff carts were originally designed in Canada. Okay, the Redicop chaff carts with the big blower systems. They kind of took that idea to Australia and revamped them. So you can see here, this chaff cart is using a conveyor system instead of a blower system. Okay, so that helped fix some of the challenges with chaff carts. However, if you are collecting the chaff into a chaff cart, you're collecting the weed seeds that are in the chaff, but then you need to do something with that chaff. That chaff needs to be grazed or burned in order to manage it, right? So there's an additional operation or an additional step there to actually try and manage your weeds. If you're burning it, you're also losing that residue. Oh, wrong way. The direct bale system is exactly what it sounds like. You are directly baling the straw and the chaff off the combine. Okay. Now those bales themselves are removed from the field and they take the weed seeds with them, which is great. But they need to be fed or they need to be processed. One of the challenges with feeding the bales is what animal you're feeding it to. Okay, so if you're feeding it to cattle, there will likely be some weed seeds that are not fully digested and still have viability. So when you go to spread the manure, if you're not processing or composting the manure or dealing with it before putting it back onto the field, you're also putting viable weed seeds. So where this caught on in Australia was those bales were actually being pelletized for sheep feed. And that pelletization process was what was actually destroying the weed seeds before it even got to the animal. Again, you are seeing a nutrient loss here, but if you're already baling the straw, maybe that nutrient loss is somewhat negligible, or at least not as big of a concern because it's already a practice that you're somewhat using. Okay. Narrow windrow burning. This one has always somewhat fascinated me. Basically, what you're doing here is you're dropping your straw and your chaff into a swath behind the combine, and then you're going and burning those swaths. Okay, so there is obviously some nutrient losses because you're burning the residue. There's also obviously a fire risk. So what you can see, this is an image from Australia, is there's limited residue in between each of these stubble rows, right? I don't often see quite that limited amount of residue in Western Canada because of us being long-term no-till. So combine fires are bad enough at harvest. I'm not a big fan of lighting a whole bunch of swaths on fire across a field and letting them go and really hoping that they stay where the straw and the chaff is and don't burn up the rest of the field. Don't love that. Okay. Now, having said that, it works really well when it works. So you have to get a slow, hot burn on these windrows for it to be effective. If you're burning and the wind is blowing the fire down the row, so it's going really quickly, you don't typically get hot enough to destroy the seeds. So it's got to be slow, it's got to be hot in order to destroy those weed seeds. But there was producers in Western Australia doing this over like 20,000 hectares of land at one point in time because they were having such resistant weed issues. Chaff lining or tram lining. This is working with chaff only, so different from the narrow windrow burning. And what's happening is the chaff is either getting put onto tram lines in a controlled traffic system or just concentrated into a row behind the combine. Okay. The whole idea here is do not disturb. You put it into the row and you don't disturb it. Because what's happening is that chaff is essentially acting as a physical barrier to emergence. So you want to think of it as essentially wood chips or wood mulch, okay, like you do in a flower bed. It's a physical barrier to emergence. It does not, from work that we've done in Western Canada, it does not reduce weed seed viability. In fact, in a lot of cases, it's actually protective of the weed seed viability. And so what that means is that if you eventually disturb it, your weed seeds are actually still quite viable and will start to grow once you disturb those weed seeds. Now, there is options because you've concentrated those weeds into specific areas. There's options to essentially conduct targeted management, right? So especially on a CTF system, you could specifically spray your tram lines. Okay, so if you're using a see and spray sprayer, something along those lines, it gives you options there to target your management to a specific area instead of broadly across the field. The one that we're going to spend a lot more time on is impact mills. So the idea behind the impact mill is that you're using these mill systems that were used for crushing coal and the like, and the weed seeds and the chaff are going into the middle of it. Now, what typically happens is you've got counter-rotating cages or something of the sort, if you will, that are spinning really quickly in opposite directions, and the material is moving from the inside to the outside. It's getting smacked multiple times by these cages or by these bars, and it breaks it all into very small pieces. When it's broken into small pieces, it doesn't grow anymore. Okay, so it processes the chaff and the residue goes back onto the field. So what was originally planned, or how this really originally worked, was the chaff went into the mill, and the straw did not get processed. So this went on a conveyor in these original systems, separate from the chaff. Okay. Now, this is how it started, was in these great big tow behind units with the mill and the separate conveyor system. This is how it's going, is units that are built directly into the back of the combines where you don't have to tow the giant machine anymore. Now the only one that has to tow the giant machine is me for research purposes, because this is what I have for research, okay? You guys can actually look at ones that are built into the back of the combine. A whole lot easier to deal with, I can promise you, having dealt with the giant monster in the field. So when we look at these physical impact mills, again, they are still processing the chaff, and the straw is coming separately through the straw spreaders, okay? So we are only working on the chaff. There are 3 brands that are fully, I will say, on the market. So the IHSD, or the Integrated Harrington Seed Destructor, the Seed Terminator, and the Redicop Seed Control Unit. These are fully on the market, fully available for purchase, for install, what have you, okay? The Tech Farm Weed Hog is at a limited commercialization stage where they do have folks running them, but they're limited numbers still. The IHSD, the Seed Terminator, and the Tech Farm Weed Hog are all from Australia. Okay, those are all built and manufactured in Australia. The Redicop Seed Control Unit is built and sold by Redicop out of Saskatoon. So we are the only country aside from Australia in the seed mill game, or in the impact mill game, and it is actually based in Saskatchewan, which is kind of cool. Now, when we started conducting research on harvest weed seed control, we felt that impact mills were probably going to be the best fit of the harvest weed seed control methods for most farms in Canada. Now, obviously, individual farms may vary, right? There might be reasons that some of those other methods are a better fit for you. But what we liked about it was that it can be integrated into the combine, so it doesn't require additional passes. It doesn't require fire or lighting the landscape on fire, which is a benefit, which means you don't have some of those nutrient losses, and it leaves the residue on the field. Okay, so it maintains sort of our no-till nutrient cycling type status. So that's why we focused in on impact mills. The other component that I like about them compared to something like chaff lining is that it is actually processing and doing something to the weed seeds to affect their viability, rather than just sort of blocking them from emerging. Now, I want to give you just sort of a quick summary of some of the research that we've done in Canada, just to sort of bring you up to speed on where we're at. We started by looking at seed retention. So we talked about that first requirement is those weed seeds still need to be on the plant. Okay, so we started looking at that with some of our most difficult weed species. And what we found, unsurprisingly, is it's species dependent. So this is a graph, some preliminary work from my PhD, where what you can see is volunteer canola holds on to its seeds really, really well. Cleavers, kind of intermediate. Okay, it starts to taper off here, and wild oat like to drop its seeds a lot earlier. Okay, now I'm only showing you one graph. I did this study at 3 locations over multiple years, and it came out real quickly that these patterns are environment or year dependent. So our weather comes into play. If we've got drought, if we have hailstorms, those make a difference on seed retention, I can tell you. Things like that, that all comes into play. It is, however, also cropping system dependent. So what is retained as a percentage in terms of something like wheat is about up here. What's retained in a crop like faba bean, which matures later, is down over here. So you see differences based on harvest timing, okay? Now we also did some work specifically for wild oat, okay, because wild oat likes to drop its seeds early. And what we were able to show is that our wild oat density remained a lot lower when we incorporated early maturing crops. Okay, so in this case, we had peas and winter wheat. Now, some of this effect was probably from competitiveness of the winter wheat, but some of this effect is also because we were able to harvest earlier, there was more wild oats on the plant when we were doing our harvest weed seed control tactics. So we were able to target a larger proportion of those wild oat seeds. Now we also looked at swathing and straight cutting. Not as big of a difference there, although there is sort of a nice little incremental bump to using swathing instead of straight cutting. Again, you're just collecting more of those seeds. Now, we also did some work looking at factors that might affect impact mills. So this was questions that I was getting, does weed seed species make a difference to how well those mills will kill those weeds? Does weed seed size make a difference? If you've got a really small seed compared to a really big seed, and we did that with canola that we sieved to different sizes so that we were at least using the same species as well. Weed seed number. Does it matter if you've got 10 canola seeds in, say, a 5-gallon pail of chaff versus a million canola seeds in a 5-gallon pail of chaff? Quick tip, don't put a million canola seeds in a 5-gallon pail of chaff and run it through a mill. It turns out you can make canola meal really well that then sticks to everything and you have to clean everything up. Chaff volume. What if you have 10,000 seeds going with next to no chaff because your crop really was hit by drought? Versus you've got a bumper crop and you've got the same number of seeds. Can you actually collect all of them? What about chaff type? Does it matter if you're looking at these seeds in barley versus canola versus pea? What kind of difference does that make, or does it make a difference? And so we did these studies. We collected chaff from a nice clean field at the Lacombe Research Station. We set up our chaff in 5-gallon pails because it was an easily measurable volume. We mixed our seeds in. We dumped it into the top of the Harrington seed destructor and let the mill do its thing, collected it, and looked at what would grow afterwards, okay? We were dusty and itchy and sore from standing on concrete for 5 days in a row, but we did it. We've done similar things with the Redicop seed control unit before it was fully commercialized, with looking at some of their prototypes, primarily focused on sort of their prototype system and which type they were using, as well as chaff volume, sort of the amount that it was processing in a short period of time. I'm not going to go through each of these tests in detail, okay? Here's sort of big picture results. I asked if there was a difference between barley chaff, pea chaff, and canola chaff. In each of these pictures, the original chaff, and you can see there's some straw in there because of the system that we used to collect it, but the chaff that we put in is on the left. The chaff that came out from those samples is on the right. Okay, you can see the difference in texture. It's super fine. It looks like flour almost, and it's a much lower volume. Okay, so it processes what goes in there really well. Again, I'm not going to go through each of those different factors separately, but if you can get it in the impact mills, the vast majority of those seeds are destroyed. We're seeing greater than 95% efficacy, and that's being conservative, okay? We are honestly typically seeing 97% efficacy or more. There are some differences. So statistically, yes, cleavers was not controlled as well as wild oat, but it was a difference of like 0.3%, okay? Very minor difference, really not something we're concerned about on sort of a biological field application scale. So what we were seeing from this was you can get it, if you get it in the mill, those mills work really well. So the trick will be getting it into the mill and really getting it into the combine, okay? Now, when we got the original Harrington seed destructor, this is the day it arrived in Lacombe, we also did some testing in the field. Okay, so this is the first pass that a Harrington seed destructor made in Canada back in 2017. We went on to 20 producer fields. We were in their fields for 3 harvests, 2017, 2018, and 2019. And we picked patches in their fields that were really good and weedy, okay? The star here is the Lacombe Research Station. All these little yellow pins, those are the fields that we were in. And again, we took the weediest part of those fields that we could find. What we found was limited impact, partly because we were only there in 3 years. Okay, so something to really understand with the impact mills is you're not going to see impact necessarily in the first 1 to 3 years. Okay, you're going to expect to see results in 3 to 5 or more years because you need to drive down your weed seed bank first. Okay, if you have a really happy heavy seed bank like we had because we picked the weediest part of the field, it's going to take time to actually drive that out. You're preventing new inputs, but what's there is already there. We're not sterilizing the seed bank, so we got to get rid of that first. Now, there are ongoing projects that I just want to bring your attention to on farmer fields with crop commissions in Saskatchewan and Manitoba in particular. Okay, so producers that are adopting these technologies are working with the crop commissions to track weed populations over time. They're using drone imagery in some of these to look at the movement of weed seed patches and things like that, okay? So there is a lot of ongoing projects. where we're still trying to track sort of over a longer term what that impact is of using these mills in the field. Okay, so somewhere to watch for more information. Now, one of the interesting things with impact mills is that we are starting to see their adoption in Canada. So we do see a lot of adoption in Canada and the US from a research standpoint. There's a lot of us working on this for research. So I'm in Alberta, and there's a whole network of US researchers working on this in all kinds of different cropping systems through the GROW network. So GROW is getting rid of weeds. I love their objective. And this is their website. It's Grow IWM, I think, something along those lines. They have a ton of resources, not only on impact mills, but also on cover crops, on other research that's being done in electrical weeding, and you name it, there probably is someone in that network working on it, and it's an amazing resource to go and check things out. Now, back in 2022, 2023, I was estimating that we had about 25 mills in Western Canada, okay? I keep in touch with the manufacturers, I keep in touch with the distributors, trying to sort of track roughly how many are coming in. They don't give me exact numbers, but they'll let me check my ballpark number with them essentially. And I wanted to understand for those producers that were adopting a little bit more about their experience. So we circulated a survey with the help of the manufacturers. Unfortunately, I did not have direct access to the customer list, so we also circulated this on X or Twitter, on LinkedIn, basically any way I could think of to get in touch with specific producers that are using these mills. The survey was completed by 10 farmers. Okay, so it wasn't a huge sample size, but those 10 farmers had 18 impact mills, which is about 60% of the estimated adoption. So a pretty good response rate that way for what I thought was out there. We got quite a few of them responding. Okay. This is sort of what the adoption timeline looks like. In 2017, we had none. 2018, we were up to 3 or 4, and then we were up to that 18 by 2023. Okay, so we're slowly starting to climb up here in terms of adoption. Where are they located? We had a couple in Alberta. The majority of them were in Saskatchewan. Okay, biggest concentration is right around Saskatoon or just north, but there is a little bit of spread sort of through this central, southern, western part of the province. Now, this does not show Manitoba. I did not get any respondents from Manitoba, but I know in that year there was 4 mills that went into Manitoba as well, and we've had more since then. Okay, so we do have adoption in Manitoba as well. Who is adopting these things? It is primarily bigger farms. Okay, 3,000 acres or more seems to kind of be that sweet spot for farmers willing to take a gamble on this or make an investment in this area. We do have one farm that was under 2,000 acres, but the majority of them were in that larger farm size. Now, one sort of misconception is that you have to outfit every single one of your combines. That's not the case, and it's not what we see our early adopters doing. There are some that are adopting all of their combines on the farm, but we also have a number that are doing a couple of their combines in their fleet. Now, how are they doing that? The combine with the mill is the one that opens the fields and does the weedy patches, is kind of how they have designated that. Now, having said that, there's obviously some logistics that come into play with that because you always need that combine available for opening the field or for dealing with those weed patches. And if it's not available, are you going to wait to open the next field until it is available, or are you just going to go, right? So there's some logistics that come into play, but you don't have to outfit every combine. You can use the combine with the mill strategically on your farm. So as an example, this farmer 10, they have 8 combines on farm and only 2 have a mill. Okay, so there are ways to do that without needing to put one on every single combine that you own. Now, what weeds were driving producers to adopt? Well, all weeds came back a lot of the time, which is, yeah, fair enough. That's fair enough. But there were also some key targets that continued to come up. Wild oat was listed by 60% of those producers, which did surprise me a little bit with what we know about the seed retention maybe not being ideal. Kochia was listed by 50% of the producers. That didn't surprise me in the slightest. Other ones that were mentioned were wild mustard, sow thistle, and cleavers. Okay, so not really surprising species to see showing up in general as problem weeds for producers. We did ask the question, like, why did you decide to adopt? What drove you to that? Reducing or managing the weed seed bank was 40% of our answers. Okay, so that's the goal. That's what they want to do. Managing current and future herbicide resistance was another one. So stopping the spread of some of those resistant weeds in some cases. Reducing weed densities, period. I just want to get my numbers down. Some of them just said, I saw this was being really successful in Australia or on other local farms to them, and it just made sense to me to put it on and to go into this area. I want to reduce chemical usage. That's what led me to adopt, okay? I want to reduce weed densities prior to adopting site-specific application technology. So this is someone that's looking at sort of the see and spray type sprayers, okay? Whether that's green on brown or green on green, they want to look at adopting site-specific application technology, and they think, geez, I got to get those densities down first to really get my money's worth out of those site-specific technologies. Now, how are they using them on the farm? They're using them in essentially all the crops that they grow on the farm. If they grow the crop, they're pretty much running the mill in it. So there doesn't seem to be any issues there. This is areas that are always seem to be of interest. What does it cost in terms of fuel use, and what does it cost to maintain? Okay, so cost in terms of fuel use averages out to 1.4 or $1.40 per acre. Okay, that's about the increase in fuel cost from running the mills. Annual maintenance cost averages out to about $1,500 a year. Now, having said that, you're going to notice there's some zeros here and be like, hey, yeah, okay, like there's no maintenance cost involved. What happened here is these are producers that had just adopted the mills, and so they hadn't actually had to maintain it yet, and they didn't want to take a guess, so they just said zero. I haven't paid anything yet. So when you took those out, this ended up being about $1,750 a year. So under $2,000 still is kind of what the average maintenance cost has been for those mills. Now, there were some challenges early on in particular in terms of maintenance. So there was a few experiences in Australia and in Canada of a steel piece or a metal piece going through the mill, whether something sheared off or what have you, and it ended up going through the mill. The mills don't like metal, it turns out. It kind of destroyed the mill and they had to rebuild it. Okay. Now, once there was a few of those experiences, the manufacturers realized, okay, this is an issue. And so they've made adaptations to their newer prototypes or their newer model years, if you will. So they've added things like magnetic strips to stop some of those metal pieces going through. They've added things like debris traps. So rocks were another one in Australia that kind of did the same thing. The rock went through into the mill and caused a little bit of damage. So we've added rock traps or debris traps. Okay, so one thing that has been really interesting to watch from my perspective is because it's such a new technology, the manufacturers tend to really be listening to those early adopters, going, what are your challenges and how do we address that in our engineering? So there's been a lot of improvements in a very short period of time as these things actually go on to farms and we realize or recognize what challenges we face on farm that you maybe can't recreate when you're just doing a prototype in a shop or something like that. Now, the other thing I will note is that the operating costs that we recorded in terms of fuel use and in terms of maintenance are low compared to other estimates that are coming out of the US. Now, we need to investigate a little bit the differences in terms of what is being accounted for. Am I just missing some parameters that they're accounting for? Is it differences in soil? Is it differences in crops? I'm not sure yet, but I do just want to flag that so that if you see other cost estimates which are higher, we're aware of that, and I'm not entirely sure what the differences are. This is what I have for information so far in Canada. Now, number one challenge being faced by producers is this. It's plugging. Okay. Now, this is across Canada and the US. Funny thing is, tough material or really green material, it doesn't flow. And if you try and force it into a mill, it don't go. And then it backs up, and then the back of the combine backs up. And it's not fun. Okay. Now, where are we seeing issues with this? Green soybean straw in the US is one of the major culprits. In Canada, kochia. Kochia is one of the big culprits here because kochia tends to stay green when we are harvesting things like our cereals. And if you have a really dense kochia patch, a lot of what's going through is green, moisture dense material. Okay. And it will plug. So some of the producers have told me 50% you are gambling. 25%, maybe 30 is sort of the comfort zone where you can take 25 to 30% of the material going through can be green. Anything above that, and you're starting to roll the dice on whether or not you're climbing in the back of your combine. Okay. There are ways to manage it. Okay. You either desiccate the patch so it dries down, you swath the patch so it dries down, or what some producers are doing is they're treating it like a slough. You cut around it and you come back and you clean it up at the end of harvest. Okay. There are options to deal with it. There is work being done by the manufacturers trying to deal with this as a challenge. But the reality is if you have really moisture dense material, it just doesn't flow as easily, right? And so that's really the big challenge. But it's something that the manufacturers are aware of and they're trying to deal with, but there are also strategies to deal with it on farm. And just know that if you decide to roll the dice, you have to be willing to also climb in the back of your combine and do the unplugging. Now, are they actually having an impact? Are they reducing weed densities? Well, some of these adopters have only had it for a year or they're just starting to run them. So I kind of stepped away from looking across all of the respondents to this survey. And I wanted to look at the longer term adopters. So 3 of our respondents who had used it for 3 years or more, okay, were reporting reduced weed densities and reduced spread of weed patches. They were estimating because I don't have quadrats out in each of their fields, so I asked them, how much do you think you reduced your weed densities? And that average estimate was about 62%. So they feel like they are seeing benefit. Now, if you've spent the money to invest in a mill, you probably want to see the benefit. So you might have a little bit of bias towards saying, yes, your densities are down, right? You spent the money on the thing. But that is coming through that they do believe they are seeing a reduction in their densities. Now, again, a lot of these folks are not using the mill on every acre. They're using it on opening rounds, on patches, and on slough or saline areas. So some of them turn it off to reduce fuel costs, and they only turn it back on when they are in those areas that have significant weed pressures or they're concerned about weed movement. Now, just a little bit of history because it is interesting. Those impact mill adopters typically are saying that is the first harvest weed seed control method that they have used on their farm. This is a significant difference from Australia, where usually chaff lining or narrow windrow burning was used first. But I think a lot of what we're seeing was in Australia, when all of these methods were being developed, it was from different farmers all kind of developing them at the same time. And what we're seeing in Canada is we've had the opportunity to look at Australia, see what they're doing, see what works, and choose which ones we wanted to use from there. And so we're seeing that those impact mills are kind of coming out as that first choice in a sense. Now, one of the questions that I also wanted to know is where are you getting your information on impact mills? Okay. Mill companies and other early adopting farmers were number 1. Farmer meetings or extension talks, social media, webinars, thanks for showing up today, ag media, online published papers, and others. Okay. The one I really wanted to highlight was the other early adopting farmers. It's one of the reasons I did the survey was to try and get information from those farmers that I can share in this type of setting, because those farmers are busy farming. They're not necessarily folks that really want to get on webinars or go on speaking tours or go on speaking engagements to get this information out. There's coffee shop talk and there's information flowing that way, but I'm trying to help bring some of the information from the early adopters to some of those wider audiences. But getting them involved and getting them providing feedback is really important because they're sources of what you want to know. I can run the HSD in the field, but I've got the old version and I've got a rental combine and I'm only doing small patches. So for how much it costs me in dollars per acre, I'm not the best source of the information. So getting that from the actual farm is really important. I also asked them, what do you need for research? What do you think needs to be done to make this viable? Efficacy on weed densities was number one, which, like I said, it needs time. We need to be able to look at these things over time because of those seed banks. Interest in precision spraying or harvest weed seed control interactions, whether or not it's affecting grain loss. There was some feeling that it might be. Whether you can use it to manage patches, how to set the combine to optimize the use of the mills, competitive comparisons of brands, return on investments, fuel costs, suitability in crops with fewer herbicides, so specialty crops. The cost benefit of managing volunteers came out, right? So if we're harvesting canola, what's the impact of managing those volunteers in our soil moisture reserves or in our soil nutrient reserves from not having the fall growth of those volunteers? Reliable operation, which basically was, can we stop these things from plugging because I'm sick of unplugging my combine? That's what that last one really comes down to. Now I asked them, how long do you think it'll take to pay off that you made this investment? What sort of time frame are you looking at to see your ROI? Now some want an ROI within 1 to 2 years, and I'm going to be blunt, I think that's optimistic. Okay? Because we've got seed banks. And especially with weeds like wild oat that have a longer term seed bank, 1 to 2 years is asking a lot of these machines. 3 to 5 years, I actually agree that I think you can start seeing some benefits in that time frame. Some are more patient, saying 6 to 8 years or even more than 10 years, it's okay. I'm expecting it to take that long to really fully pay off that upfront investment. Now I've kind of danced around it a little bit. What is that investment cost? It's about 100 grand. Okay. Now each of the brands are a little bit different. Obviously, if you're looking at the Australian brands, it's in Australian dollars. By and large, with install, with shipping, with whatever, you're looking about 100 grand. Okay. The other thing is you really want to be running these on Class 8 combines or higher. Lower than that, there's a horsepower limitation, which cuts down the number of farmers right off the bat that feel as though they can invest in these types of technologies. So there is work being done with something called directed energy. It's a concept by Global Neighbor, where they are looking to use basically light spectrums, infrared light and blue light, to reduce weed seed viability. Now, there's been some work done in Australia and some work done in the States that is showing positive results. But the goal here is that because you're not physically processing all that residue, it would reduce the horsepower requirement, potentially be available for smaller combines, and hopefully have a reduced cost as well. Now that is still in the testing phase. There is not a commercialized option yet, but I just want to basically share that we're aware of the limitations of the upfront cost and the horsepower requirements, and there is work being done to try and make the impact mill idea or another harvest weed seed control option available for smaller combines and at a lower cost. So ongoing research there. We are beginning to see adoption. I would right now estimate that we're between 40 and 45 mills in Western Canada. There are some opportunities through some of, say, the sustainable cap funding with the provinces. There are some opportunities to get part of the mills paid for with an application for those funds. And I know 2 mills were actually purchased in Manitoba last year with SCAP funding or partial SCAP funding, I should say, covering some of those costs. So there are some opportunities that way to try and deal with that upfront cost a little bit. There are obviously challenges, things like wild oat that are dropping its seed early, things like kochia that is green at the time of harvest. There are challenges and there are strategies that are needed to deal with those challenges to adopt this weed control technology. But we also do have interest in non-weed benefits. So, we're interested in the idea of, could these mills be used to help manage fusarium damaged kernels? Could these mills be used to help manage our volunteers and actually help us with our soil moisture reserves or our soil nutrient use, things like that. So there's some interest in those non-weed benefits and some proposed research going in hopefully this year to start looking at some of that. Now, I also wanted to mention some ongoing research that we do have where we are tracking wild oat patch expansion with mills versus without mills. So the idea is if you have a herbicide-resistant wild oat patch, can you keep it a patch in your field instead of spreading it through the field and now having herbicide-resistant wild oat across your entire field? Because wild oat is a little different than kochia, right? The wild oat seed that drop right beside the plant, unlike kochia, which is going to tumble. So if it loses its seeds, it's going to lose right by the plant. And if it doesn't lose its seed, hopefully with the mill, you can prevent it from spreading that way. So we're doing this on a farmer's fields in Saskatchewan. I will say tentatively, this is preliminary data. All patches do seem to be growing, and we're in our third after 3 years of this study, okay? But there is a big difference between our unmilled growth rate, which averages 467% growth from the patches at the start to the patches now. Now, I will mention that there's a lot of variability, and where we are seeing the highest growth rate is after lentil, which makes sense because they're not as competitive a crop, right? Our milled patches have grown at about 57%. This is not a typo, 476% versus 57%. Now, I'll be upfront, it's not a statistical difference because there's a lot of variability in terms of growth between the patches, okay? There's a lot of variability there. We got to look at other ways to manage some of that variability, but there's a definite difference showing up for how much those patches are expanding when you have the mill on versus when you don't. I'll also add that I've heard this directly from a producer about kochia, that they have a mill on their farm. They chose, because that mill combine was busy and they were in a hurry, they chose to put a combine through a kochia patch that did not have a mill on it. And they said, oh boy, can you tell the next year how much that kochia patch has expanded versus where they used the mill. It's not that the kochia patch is gone, but the kochia patch is in the same place it was last year instead of spreading across the field. Okay, so that's the idea there. Again, lots of variability. This is being funded by the Sask Ministry of Ag as well as Saskweet. So a big thank you to them for funding this research. It's ongoing. We got another harvest this upcoming field season in 2025. And we'll see what the patches look like by next year as sort of the end of the study. So with that, I do want to thank you for tuning in today. Thank you for your time and your attention. If you want to ask me questions not on this platform, or if you think of something in a week from now that you should have asked me, I'm pretty easy to track down. I'm on pretty much every social media that exists. My email is right there. If you Google me, you can probably even find my phone number without too much difficulty. Feel free to reach out and chat at any time. Thank you very much.
Thank you, Breanne. That was excellent. Lots of good information in there. Um, so yeah, we got some time for some questions. I'll just remind everyone that you can shoot some questions in the question box there, and we'll share the CU credit after the question period here. Alrighty. So first up, I got if you wait for the kochia patches to dry down to reduce plugging, how much are you increasing your risk of not having those seeds go through the combine?
So kochia is interesting. Its seed retention actually looks quite good. When kochia is green, those seeds are not yet mature. So waiting for the plant to mature, you still see relatively decent seed retention because that plant tends to hold its seed until it actually starts to roll a little bit more. You see some losses, obviously, um, but it has relatively high seed retention. The one, I guess, kind of watch out with kochia, since we're talking about it, is that in that bottom 6 inches, so your cutting height, if you're cutting at 6 inches or above, in that bottom 6 inches, you can still have a couple thousand up to 5,000 seeds. So you're not getting all of those seeds right off the bat, unless you're cutting ground level. So if you're harvesting peas or lentils, you might get them. But if you're cutting wheat or canola, chances are you're also leaving a couple thousand seeds at the base. But those ones are, again, at least ones that aren't going to roll and take off on you, hopefully, and spread across. But seed retention and kochia, even waiting till maturity, is generally pretty good.
Gotcha. No, that's interesting. Um, Next question here I've got, have you noticed if using impact mills increases soil compaction compared to not using the mill, just from the any extra weight?
Oh, I don't know if we've actually looked at that at all. That's an interesting question. Um, I'm not aware of any work being done on that globally, if I'm honest with you. I don't think they've even looked at it in Australia, where they've been using them longer. Um, and I would have to actually ask the manufacturers what the weight is of an impact mill set. Um, I can tell you it's less than the giant beast that I have dealt with. Um, but I do not know in terms of soil compaction, and I don't think anyone has looked at that yet. You may have just given me a research idea, so thank you.
No, that's great. Yeah, like I imagine it would be small compared to the combine, but not
I would think
perhaps
so.
not negligible,
Yeah.
but interesting. Next I have there been any cost analysis on the use of the mill compared to cost of herbicide resistance and seed cleaning? I think they're asking just like, yeah, I know you touched on this, but people want to know what.
Yeah, it's something that is really difficult to do because we don't necessarily know what herbicide options are being used to manage the herbicide resistant weeds or what the seed cleaning costs are or that type of thing. And you have to parameterize it over the right number of years in a sense, right? So if you're looking at it for wild oat, you need to look at the impact of the impact mill. That's a lot of impacts. Um, of the impact mill over say 5 to 10 years, which is difficult to do at the same time with herbicides. So it's almost like we need the impact mills to be used longer in the fields for us to actually start making that comparison, if that makes any sense.
Yeah, no, I think that's a good explanation. It'll take some time just to kind of start seeing the
Because
impacts.
in the first year or two, the herbicides and the seed cleaning are going to probably outweigh your impact mill because you're not going to see that the result of using the impact mill necessarily in those first 2 years. So I think it's something where you're going to see sort of the herbicides and the seed cleaning up here and the impact mill down here in terms of economic benefit, and over time that's going to shift is my hypothesis.
All right. Okay, next question we got. Are you seeing limitations on combine header size or ground speeds in order for the mill to keep up?
It depends who you ask. Some folks are saying it makes no difference at all. They turn it on and they go. Some folks are saying they have to slow down a little bit to give the mill time to deal with the residue. It may be a factor of how big the crop is. The manufacturers typically say, when I've asked them this question, they say the mills can handle what the combine can handle. So I'm kind of getting mixed messages at this point in terms of if it's an actual challenge and if we do need to be slowing down, if we're losing some efficiency there or not.
All right. No, that makes sense. Yeah. Um, Next question I got. Is there any nutrients or moisture capture being lost with the finer material? How would it work with cover crops? Like, I understand maybe there's a concern of less residues on the surface.
Yeah, so I mean, the majority of your residue is still coming from your straw, right? The chaff fraction tends to be a relatively small-ish component of that residue. The idea or the expectation is that we'll see that residue degrade faster, but whether or not there'll be any impact on moisture retention, I don't know. I can tell you the chaff itself, when we've done greenhouse studies, is still enough to hold moisture and also grow mold if you have too much of it in there. So it will still hold moisture. There will probably be some impact, but what scale of impact, I don't know. In terms of use with cover crops, I wouldn't think it would be an issue, significant issue for establishment if you're doing a fall cover crop. Um, there has been some questions about, well, I kind of use my volunteer canola as my cover crop. Obviously, you'd have an issue there if that's the intended cover crop. Um, but yeah, it's some of those questions are just we don't have enough use of it to actually start even gathering data in a sense.
Right. No, that makes sense. I like that canola as a cover crop. I do that sometimes too. Um, Does processing the chaff/straw to be that fine see an increased benefit from faster residue breakdown, as residue is contributing to organic matter/nutrient release sooner than typical chopping?
So again, it's something we've thought about, and it's actually when I talked about managing fusarium damaged kernels, one of the things we've been thinking about is that you would expect there to be a faster degradation of the residue. So then, from a fusarium perspective, would you see faster degradation of the inoculum? Um, possibly, possibly. Again, it hasn't really, even in areas like Australia, they haven't really looked at it. Um, and in a large sense, it's because they were so against a wall with ryegrass and trying to manage resistant ryegrass that they will kind of take whatever happens to come with it as long as the ryegrass is controlled. So there hasn't been a lot of necessarily interest in digging into some of these questions on what is it doing to the ecosystem in those areas that have the long-term use where they could actually do it. So it's things that are kind of being left for some of us that are now interested in it. Well, we need the use to go up so we can actually start tracking some of it. Because it's just
Right.
not something I can do in small plot because the mills don't go real well on plot combines.
Gotcha. No, yeah, we'll just need some time, I think. But that's interesting to think about. I just got one more question for you. Um, did your study look at how much extra time a harvest could take with an impact mill? Would it slow you down, essentially, I guess?
Yeah, so it's not something I specifically asked on my survey. Um, it is something that I've thought about asking in the future. Some of the farmers that are using the mills in the US have said they've had to slow down. Um, when we use the seed destructor in the field, it's not something we could document because we were just harvesting our small area, so really not representative of actually operating the thing in the field. Plus, we had the big tow behind unit, so it wasn't representative of what producers are using now. Again, what I've heard is really big bumper crops. You might have to slow down a little bit to let the mills keep up. What the manufacturers are saying is if the combine can handle it, the mills can handle it. So I'm kind of hearing both sides of the story and haven't had a chance to actually dig into it myself.
No, yeah, that's a good explanation. Yeah. That was the last of the questions I have, so I just want to thank you again. That was such a great presentation. I'll